Hello everyone, this is Mr. M from Algebra Lessons. In this video, we are discussing here about Euler's formula. So, here we are going to prove this formula. To prove this formula, we should have some basic information. Possibly in your lesson that previously discussed in your grade level, you may discussed or you may gone through these concepts. So before starting my explanation, let me write those concepts here. So this is about the equations. So we are actually going to write the exponential theorem result here for e raised to x. So e to the power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, etc. and so on. And this is called the exponential theorem. And similarly, sin x, and cosx has this kind of an expression. Sin x can be expressed as x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus etc. That means alternate signs change. Similarly, for cosx, we have the expression 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus etc. So you can see that there is an alternate sign change, but all terms of this exponential term e raised to x is positive. And you actually may heard about this e. Approximate value of e is approximately it is 2.71828. Usually some calculus teachers are actually mentioning this as Andrew Jackson number, the famous US president, because this 2 represents the number of terms he elected, and he was the 7th American president, and he was elected in the year of 1828. So that's why some teachers are actually calling it as Andrew Jackson number. So we can proceed. Our objective is to prove the Euler's formula. So first we need to write the Euler's formula. So the Euler's formula is this. So these are the components we need for our proof. Okay, so Euler's formula is stating like this: if x is a real number, e raised to I x can be written as cos x plus I sin x. So this is what is called the Euler's formula statement. We want to prove it. Okay, we can try. So from this result, so these are the result that you already discussed in your previous lessons in your class. E raised to x is 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial and so on. And sin x is x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial, and cos x is like 1 minus x squared by 2 factorial and some even powers. So we actually using this Euler's formula to connect trigonometry and the complex numbers. Okay, so How can we do that? Even we have these expressions without any loss of generality. Without any loss of generality, we can extend these definitions. Okay, these definitions for complex quantities as well. So instead of writing x, I'm going to write. So we can start the proof here. E raised to z, okay, e raised to z is equal to, just replacing x with z, so 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus etc. And sine z can be write as z minus z cube by 3 factorial plus z to the power 5 by 5 factorial minus etc. Similarly, a cosine, cos z equal to 1 minus z square by 2 factorial plus z to the power 4 by 4 factorial and minus etc. And so this is actually right in terms of complex numbers. In terms of a complex number with c, we can write as it is. Okay, let me mark each as one equation. This is equation number 1, this is equation number 2, and this is equation number 3. So now you please try to put a substitution for z in equation 1. So in equation 1, so we can write the equation here. E raised to z equal to 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial and so on. So I am putting a substitution here. Put z equal to ix. Okay, that is my substitution. So let me continue with this substitution. So what will happen to this equation? So equation become e raised to ix equal to 1 plus ix by 1 factorial plus ix square by 2 factorial plus ix cube by 3 factorial and so on. Okay, so as you know, I square is equal to minus 1 is the value that you discussed in your complex classes. Okay, so we can rewrite this thing like this. So this is 1 plus ix plus 1 factorial divided by 1 factorial, and this is I square x square. I square is minus 1, so x square by 2 factorial. Okay, and this is I cube. I square is minus 1, so I cube is minus I. Okay, so minus I minus I times x to the power 3 by 3 factorial and plus next term will be x to the power 4 by 4 factorial and so on. It will go like this. Okay, and if you can combine the real part and imaginary part of this expression, what will be the result? So that will be 1, and see here we have a real part, so 1 minus x square by 2 factorial, and here we have a real part, so that is plus x to the power 4 by 4 factorial and minus alternative sign difference will come there, and plus the imaginary terms. This is an imaginary term, this is an imaginary term, so plus I times x minus x cubed by 3 factorial, okay, x cubed by 3 factorial, because we have an x here, because 1 factorial is 1, that is why I wrote here only x, so x cubed by 3 factorial, and plus next term will be the odd term, that is x to the power 5 by 5 factorial, and minus, and so on. The term will go like that. And from equation 1, 2 and 3 we used equation 1, and from equation 2 and 3 we can say that this represents cosx, and this represents sin x. Okay, so we can conclude this: e raised to ix is equal to cos x plus I sin x. So this is what is called the Euler's formula or Euler's theorem.